Okay. All right. Good afternoon, Angelica. All right. So, do you go by Angelica or just Angel, or do you have a
Uh,
short
well, people call me Angie, yeah.
Angie?
Hmm.
Okay. Okay. All right. All right, Angie. Okay. So let's look at. Okay. Oh, this is something new. Okay. All right. So going through, and there's a lot of material. Okay. Here. Okay. So module number two, what is, so by going through module number two, so let me actually just talk to you for a second.
Okay.
What did you get the feel of? What
A
is
lot
module
of a
two
lot of
about?
charts.
Charts, okay? So, did you attend the first meeting on Monday?
Yes.
Okay, good. Okay, so what did we talk about? So did I give you the overview of your what statistic is all about? What is statistic?
No, well, that time I had came in late because it wasn't allowing me to like log in. So I was there
Mm-hmm.
around, I want to say maybe 2:40.
Okay. Then, were you able to watch the recorded lecture?
No.
Okay. So there's a recorded lecture that is available for you to actually click and view, right? Okay. So I think you should be able to actually click on one of those, and then you can actually view it, which is pretty much the same lecture, right? But what the overview of statistic is all about is just information and studying that information and how to actually get that information, right? Okay. By definition, statistic is what we call the sample data, okay, and analyzing of the sample data. Okay, so what we're trying to do is we want to figure out information about a population, okay, and that's what we're concerned about. And say population, some populations are, say, nearly impossible to actually accumulate those data, right? Say suppose you, like I said before, if you are in module number one, it says, oh, you want to figure out how many percentage of men who like color blue,
Hmm.
right, in the United States. Then in order to gather that data and to get a precise percentage, you have to actually what? Survey how many people, how many men.
The men in the U.S.
Yeah, men in the US. How many are there? There are probably 100 million people, right? Is it feasible for us to, for you to actually go and survey every single person out there,
No.
all men? No, it's almost, so you have to have a lot of resources. You probably have a like team, not just one team, probably like multiple teams to
Hmm.
actually go out and then survey all these people and gather information, right?
Hmm.
So it's daunting to actually get that data, right? So what we do is we take a sample, right? Okay, so it's got to be a simple random sample, and then we got to figure out there, and then we got, if we take in a right amount of sample, and if it's randomized, then we know that that sample should roughly represent what? The population. Okay, so we're trying to estimate the population. So, oh, you're like, oh, you asked me, oh, how many men, what's the percentage of men who like color blue? Like, I don't know yet, but I could actually try to figure them out
Hmm.
without using too much resources. So I can maybe survey, 1,000 people in California, send them an email, right? And then 1,000 people in Seattle, 1,000 people in New York, 1,000 people in Texas, whatever it is, right? I randomize and send those people and then gather their information. Okay, so now once we gather our information, that comes, module number two comes into play. So what do we do?
Make a chart.
Good. How do we make a chart? Before we actually make a chart, what are we supposed to do?
I'll get the calculations and all.
Mm-mm. What do we need to do? What's the first thing? Let me actually go. What's the first thing that you, let me see. What's the first thing that's said on module number one? Can you go to module number one? What's the first thing that you said it says on module number one? Data is information.
Oh yes.
Besides the data is information, what else does it say?
Observational unit.
Also, no. So it says in the in the top, it says data is what? And that has a blotch on it on module number 1. So let's see. Let me see if I can share that. What does it say?
Oh, data is messy?
Messy. Very good, right? All datas are messy, right? Then what are you supposed to do? Like when you gather information now, suppose now here I'm going to share, right? Data is messy. So the objective in module number 2, right? The learning objective, we want to create Yes. Can I give you a call back? I'm right now in a lecture. Yeah. I think I'll be free around 4 o'clock. Can I give you a call back at then? Okay. Okay, great. Thank you. Oh, sorry about that.
You're good.
All right. So here, that was an important phone call I was waiting for, but it came out at the wrong time. So what we want to do is, oh, someone came in. I just want to say hi. Oh, Justin. Hi, Justin. You still don't have your cam on? Please have your cam on. Okay. All right, so how to create, so the objective here is going to be how to create and use frequency table, how to create and use two-way table, how to make use of data bar graph, and how and why it is different from histogram, how to make / use a pie chart, how to interpret other visualization of categorical data, how to create, interpret dot plots, how to create, interpret stem plot. Okay, so this is the learning objective. And you went over this yesterday, right?
Yes.
Okay, with the tutor or trainees?
Oh, no.
Oh, you went through this by yourself, going through the module on Canvas. Okay, so basic idea is like where I left off is once you collect the data and data are messy. Okay, so for example, what you see over here, okay, what do you see for this first table here? Now that we collect the data, we need to make it usable. Data is messy, right? Typically, raw data, right, comes in the form of spreadsheet, similar to that of error types and misunderstood answer and all kinds of other problems, right? So therefore, what we want to do is organize it. Okay, so module number 2 is all about how we organize, different ways to organize different type of data. That's what we're doing right now, right? One way to actually organize it is using what we call the what?
Frequency tables?
Frequency table, okay? And there's another frequency table here. So far, so good, right? So let's look at and honing on the first frequency table. What does the first frequency table gives you? What information does that provide?
The least favorite Skittle colors?
Good. Okay. So can I ask you 2 questions here? What is your observational unit and what is your variable here?
My observational unit is the people he asked which these favorite Skittles the color they liked.
What are we observing?
The least favorite Skittle color.
A little bit. So you're being too precise here. What are we observing? So if I ask you, okay, I want to measure the average height of Cerritos College student, average height of Cerritos College student, right? What will be the observational unit?
The students?
Students, very good. So right here, if you're looking at this table, frequency table, what will be your observational unit?
Skittles?
Skittles, very good. That will be your observational unit. Okay, so you need to know how to identify your observational unit and what are variables. So in this case, every Skittle varies, right?
Mm-hmm.
By how? How do they vary?
By the colors?
By colors, very good. So therefore, your variable is considered to be what?
Colors?
Color, very good, okay? And like they say, the data is what? Okay, a raw data is very what?
Messy.
Messy. Okay, when you actually collect this data right here, this is never in this form, this pretty form right here in table form. So if you open up a bag of Skittle, what do you get? So you say, oh, okay, oh, a red came out. Oh, orange came out. Okay, green came out. Purple came out. Purple came out. Yellow, 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 and so forth, right? And this is basically raw data, right? You're like, huh, that's no good. And then we keep going and saying, you know, dot, 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 right? And then we keep pulling out and then, right? Okay. How do we actually better organize this?
By separating them into colors?
Very good. So I would actually, you know, for me, I would probably, you know, take a bowl here, take a bowl here, take a bowl here, take a bowl here, take a bowl here. And then I'll say, okay, let's just say that the first bowl represents the red color. Okay. And then the orange. And then the yellow. Okay. I'll just go by their listing here. And then we have the green. And then we have the purple. Okay, so far so good. And then whenever the red Skittle comes out, I'll just dump it in that red bowl, right? Okay. Whenever the orange one comes out, then I'll dump it in the orange bowl. Okay. In this right here case, right? And once we go through all the Skittles in the bag, then you have an organized form. And this basically is an organized form of this right here, the bowl. Get the idea? They're saying that, oh, now once a week, I counted all the what, all the not M&M Skittles in the red bowl. I counted that. Oh, there are what? There are 23
red.
Right? 23 reds, and there are 44 yellows and 44 oranges and so forth. Right? Get the idea? There's a specific terminology for this. Okay, these are called the
frequency?
Bins, like garbage bin. Rather than I called it bowl in this case, but usually we call it, right, separating different bowls, or what we call bin. Yeah. Right? These are called the bins, or in technical term, also called classes. Okay, different classes. Okay, so far so good. Okay, now let me ask you one more specific definition of your variable. What type of variable is this right here?
Skittle, least favorite Skittle color.
So what type? So remember the type of variable that we have, right? So let's look at, let's see up here, type of variable. Let's go on to module number, where is it? Number 1. Okay, what type of variables?
Oh.
We have 2 type of variable. It separates from what? Categorical or numerical, right? So now let's go back. So we have, what type of variable am I working with? What is the variable?
Categorical.
Why is it categorical?
Because it's the characteristic like a color.
Right, very good. Characteristic of different colors, right? So this is considered to be a categorical data frequency table, categorical frequency table, right?
Yes.
Okay, categorical. Okay, whereas this one right here, if you look at this one right here, categorical or numerical? What is your observational unit?
Observational unit is the pogo stick.
Pogo stick, or how much distance, right? Right. Okay, so it's a pogo stick, right? Miles completed by via pogo sticks, right? So a person, basically, you're observing a person on a pogo stick, right? That's your observational unit. And what is your variable in this case?
Variable would be the miles.
Distance, right? Or distance covered by, or miles completed by using the pogo stick, right? And in this case right here, is your distance or miles, whatever it is, right? Is that a variable that is categorical or numerical?
Numerical.
Why numerical?
Because
It's numbers, right? Basically, right? Distance number, right? So far so good, right? So therefore, this is a numerical data. Okay, numerical data frequency table. Okay, numerical frequency table. So far so good. Okay, one thing I want to actually kind of point out here is that in the categorical, right, it is very distinct that your bin or classes, your categories are very distinct, right? Which is color, right? So red, your orange color is not gonna go into red, right? Bowl.
Yeah.
Okay? Your green Skittle is not gonna go into the red bowl, right? Get the idea. It is distinct. So we label those. If you put it in, that's then mistake. That's an error. Okay. One thing, what's the difference between categorical and numerical is that numerical is hard to define your bin. And sometimes they will define it for you. Most of the time, you have to actually set those bin. Okay. And in this case, what do you notice about the bin here?
For the numerical one?
Uh-huh. So this represents the bin, right? Which is your category of colors: red, orange, yellow, green, purple. So therefore, what do you notice about the bin up here?
Their numbers?
Right, number of miles, right? So what is the width here? Bin width. Every what?
Every 2.
Few miles. Very good. That's right there. So they will specify, okay, your bin width right here. So rather than going through here, okay, so it's going 0, say 2, that's 4, that's 6, that's 8, that's 10. Oh, let me erase this and make this a little bit larger. Okay, something like that, right? Get the idea. Okay, so now, okay, suppose if I have a raw data. Justin, are you there?
Yeah.
Okay, so I still cannot see you, right?
Oh, I got my cameras on my.
Okay, so now suppose I have a raw data. So you notice that people who actually, number of people who actually measure their distance on their pogo sticks, right? Pogoing, right? Okay. Be able to, there are 45 people who are able to travel from 0 to 2 miles. So let's say that, okay, we have 0. I'm horrible in pogo stick. 0.2 miles, right? I don't know how I could do that, right? My kids, they could go on forever on pogo stick, right? Okay, one travel, the other person travel 1.75 miles, right, on a pogo stick, right? One of them travel 2 miles, maybe one travel 5 miles, one travel maybe 7 miles, and so forth, right? Okay, now if I ask you, so if this is the bin, right? So let's just call this the container. So we'll just consider this to be the container where it goes in, just like the bowls that we actually represented up here, right? Okay. So this person that travels 0.225 miles, where does that person go in?
Between 0 and 2.
It's between 0 and 2. We will go in here, 0.25 miles right there. So far so good, right? Okay. What about 1.75 miles?
The same bin.
1.75 miles. What about this 2?
Between 2 and 4.
Between 2 and 4? They're like, huh?
Oh no, on two. Sorry.
Excuse me? Which one does it go in? Does it go into the bin number 1 or bin number 2?
2.
How do you know? Because this is going from 0 to 2, this is going from 2 to 4. It's right on the cusp, right? 2 is exactly right there, right there. Where does it go into? They're like, oh, that's confusing, right? Numerically, right? If you have a numerical data, it's not certain, it's not clear cut like here. Like red goes into red right here, right? Red goes into red here. Orange goes into orange right here, right? Yellow goes into yellow right here. It will not go in between anywhere, right?
Yeah.
But numbers are a little bit more confusing. Okay, so you got to get that fixed, right? That is one of the criteria. Okay, Justin?
Okay.
Okay, so here we have what we call the universal rule. Okay, so when we have ranges of numbers, so for example, okay, so the first number is included onto that, include, this right here, exclude. Okay, include, oh, I can't spell. Include, exclude. And that's important later on when we're creating and understanding which one. Because we have to have statistician or scientists as well, right? Okay. Scientifically, they have to have a universal rule so that one does not confuse from the other. They're like, oh, you have a contradicting rule, right? Then one might put it into bin number 1. Another person might put it into bin number 2. No, that shouldn't be the case. Okay, we have to have a universal rule. They're saying that you include the first number and exclude the second number right there, the range ended, right? So which means that where does 2 fall in?
Group 2.
Group 2, it goes into here. Very good. Get the idea, right? Okay, and this is considered to be bin width. So we have bin width of 2 miles. Okay, so far so good. 0 to 2, 2 to 4, 4 to 6, right? Okay, so if I ask you, okay, where does the 8 will go in? Where does 8 go in?
Between 8 and 10.
Between 8 and 10, very good. Get the idea. Okay, now you know exactly where it goes in, right? Okay, and this is one way to actually organize them, right? Organize your numerical data, right? Okay, so again, so once we collect the data, we need to organize it in a way that the data is not messy, right? Okay, so it's easily readable. Okay, one method to doing this is putting into a table. In this case, we have a categorical frequency table and numerical frequency table here. As you can see, as the name implies, frequency table records how often a category occurs. These are especially useful for category data, especially used for categorical data, right? But can be used for numerical data by creating categories from the range value, right? So we categorize into range of value, and this is the range value, that's the range value. And it's always including, we do it in, and then that's excluding, okay? Do you see that? We have a bracket means inclusion, parenthesis means exclusion, and that's another way, algebraic way of putting it into what we call the interval notation. You heard of interval notation before in algebra?
No.
Like, oh, I know it's been a while. I know. Get the idea, right? As you can see, the frequency table above lists how many times a data value occurs in the collection, right? So this tells you the frequency, how many reds are in, right? How many reds are in that Skittle bag, how many oranges, how many people who actually, pogo sticked, right? 0 to 2 miles, there's 45, there's 15 people, there's 8 people, and so forth. These are just frequency, number of data value that goes in. Okay, so far so good?
Mm-hmm.
Any question? All right, so tally mark. Tally mark is a good way because suppose that you're doing, right? So you're in say, so say you're in I guess sports. What do you, a stadium, right? In a stadium, and then you want to figure out, Angie, what sports do you play?
Softball.
Softball, right? Okay. You're like, say, okay, who's UCLA is a good softball team, right?
Mm-hmm.
Okay. And we have USC, their rivals, pretty much, right? Okay. So we want to figure out, out of these two, which school do you want to go to, right? Say, if you have only those two choices, right? Okay. Which school do you want to transfer to and play softball, right? And then you collect the data, right? You're going to say, there are like 1,000 people there, right? In the stadium. And those are all softball players, right? A women's softball player. You're like, okay, raise your hand, and then say who wants to go to UCLA. Maybe half the people actually raise their hand, right? And you count, and they're like, I got lost in counting, right? And let me go back. You don't want to be doing that. You go, one, 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 one. Okay, there's another one, 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 one. There's another one, and so forth, right? And then you're like, get that right. So rather than doing through this, tally mark is a good way to kind of organize your work. And then once you actually figure them out, you could actually count those, tally marks afterwards. And we don't have to start counting in the beginning. Get the idea? It's just another form of organization. Okay, so far so good. And another form of organization you saw is the dice, right? You went through the dice app with your training, right?
With the canvas.
Yeah, canvas and going through the StatCrunch, right?
Mm-hmm.
Yeah, so good. You're good with that?
Yes.
And they did the tally marks through that as well, right?
Yes.
Right. So they're saying that, we have 1 dice, 2 dice, 3 dice, 4 dice, and then they go, okay, 1 came out 1 time, 2 another time, and so forth, right? That, right? And then they tallied it up, right? Okay. Mm-hmm. That's another way to organize it. Of course, there's another organization here, all different ways to organize different type of data, right? So two-way table, which is also known for, another word for two-way table is contingency table, and it's most likely, if you have a contingency table or what we call a two-way table, is what we consider multivariable or bivariate data, okay? In this case, bivariate means 2 variable data, right? The 2 variable that you see here in the example is what? What is a 2 variable, Justin? What do you see here?
The students.
Age group. And either they, right, ate their breakfast or not, right? Those are the 2 variables there, right? Okay. So here, the first cell corresponds to 40 students between ages of 10 to 13 who ate what? Breakfast. They give you a lot of information. You notice this right here, right? 40 students between ages of 10 and 13, who ate breakfast. Okay. Angelica and Justin, are you guys a breakfast person or not a breakfast person?
Breakfast person.
Breakfast person.
Yeah, I think there are several people who are not a breakfast person in the previous session, right? there are people who do not always skip breakfast. Like my brother and I, we're like, night and day pretty much. I always eat breakfast. I think the breakfast is the most important. I love breakfast. Like, breakfast burritos. Oh, I love it. I like pancakes, waffles, all these sugary stuff. My brother hates breakfast. He will skip breakfast whenever possible. He'll never eat breakfast, just eat lunch and then on. Yeah, so anywho, right? So bivariate data here in organization, right? So we have what we call the column total and we have the row total. The row total, as you can see, row represents the age group. So there are 54 students, right? 54 students that are between ages of 10 and
13.
13. How many students do we have altogether between 14 and 17?
36.
36. It seems like as they grow up, they start skipping more breakfast, right? Okay. Looks like it, right? And then the column total, we have 52. Okay, who eats what?
Eats breakfast.
Breakfast, and there's 38 altogether that
Skips
breakfast. And what does this 90 tell you?
The total amount of the eats breakfast plus the skips breakfast.
It's the grand total, everyone involved, right? It's called the grand total, okay? So it tells you right here, 90 students altogether, right? All together from both age groups, right? And that we survey who either eats breakfast or skips breakfast, okay? So this is just another way to organize your data, right? In a table form. In this case, a contingency table form, okay? So far, so good. With this, later on, you'll learn how to actually figure out more information. So suppose that if I ask you, what percentage of those people who ate breakfast are from, right? Let's just say, what percentage of age between 14 and 17 eat breakfast?
14 and 17 eat breakfast.
What percentage? How many
13.
how many are in, so how many total students from 14 to 17 age group?
36.
36. Out of those, how many eat breakfast?
12.
Oh, so therefore I can actually figure out more information saying, 12 out of 36, right? Eat breakfast from the age group of 14 to 17. What percentage is that? 1 out of 3. Or we could say 33.3333%, right? The idea, then I can actually figure out percentage-wise too. So we could actually gather, organize our data, and then figure out information. Data is information, right? Oh man, she could hit that high note. I can't do that. All right. So far so good?
Yeah.
Okay, so I know that I'm presuming that you guys went through this on your own already. But going through it over again with me should make a better sense. Yes?
Yeah.
All right. So again, all we're trying to do is different way of organizing data and how we organize it. Depends also on what type of variable that you're working with. Okay. So specifically, we're looking at this bar graph and what we call the histogram. There's two types: bar graph or what we call bar chart. Right? Like histogram, bar chart use vertical columns to denote frequency. Okay, so frequency here. Okay, the big difference is that the bar chart are only used for categorical data. Bar chart or bar graph are only used for categorical data. Okay, and histogram is only used for numerical data, okay? Categorical and numerical, okay? So far, so good. One detail that helps you show that the bar chart have, okay? And looking at this, that's one of the difference between bar chart or bar graph and histogram. Can you just by looking at these two graphs here, histogram and bar graph, what other difference do you see? Just, it's not a trick question. Look at these two right here. Look
No
at
gaps
these
and gaps.
right here. Huh?
Well, there's categories and then number ranges and then gaps and no gaps.
Very good. Oh, you need a MVP point. Remind me, right? So this right here has what we call gaps. So which, in this case, bar chart or bar graph, bars do not touch. Like, oh, that's a huge. Okay, whereas in histogram, bars touch. Okay, so far so good. Okay, one other difference that you see is that bar graph, right, does not have inherent order. Whereas in this case, in numerical histogram, we have order. What do you mean by inherent order, right? Okay, so looking at this bar graph right here, does USA, the bar USA, does it always have to go first?
No.
For me, yes, because I'm a United States citizen. But no, you're right. No, you don't have to have the United States, right? That goes first. I could actually have the UK be the first bar and United States be the second bar, right? So your bar chart or bar graph might be different than what? Mine, depending on how you order them.
Yeah.
Right? Because there is no inherent order. But your histogram and my histogram will look exactly the same. The histogram will not change because the inherent order for numerical data is always ascending order from smallest to the largest. Get the idea? Okay, we have order going from 1 to 150, 150 to 250, 250 to 2 to 250, 250 to 3, 3 to 350. Get the idea, right? We have that inherent order, whereas in this case right here for bar graph, we do not. Okay, so those are the kind of detail that you're looking for. Of course, all they want to emphasize here is that there's the two different method, right? For categorical, we could use a bar graph to organize our data in what we call the pictorial form. And we have a histogram, we could organize our numerical data in pictorial form, okay? Why is this graph so important, these graphs? Because graphs help us to visualize, okay? So later on, this histogram is going to be immensely important because we want to figure out using the graph if the graph is symmetrical, if it is skewed to the left, skewed to the right, and we look at it in point of view from graph. How does your graph? We want to see the shape of the curve, we want to see the center, and we want to see the spread from the center. Okay, and that's what the three characteristics of the graphs that we're looking for later on. Okay, all right, so let's talk about relative frequency here. What is relative frequency? Okay, Justin, can I ask you the relative frequency? What is relative frequency?
I'm not sure.
You can read right here. What does it say?
These are called by converting the it says by converting the actual frequency into percentages out of the total number of data.
Yes.
Now, if you can scale the vertical axis with percent instead of counts.
Right. So you're converting actual frequency into percentage. This is the key word here, actual frequency into percentage. And in order to actually convert it into a percentage, what we need is basically the total. Okay. So for example, let's go over here. So we can actually convert this right here. Can I erase this portion right here?
Yeah.
Can I erase that? Okay, so we have the frequency table here. We could actually do a relative frequency table. Okay, so relative. Usually relative frequency is in decimal form, but you could also convert it into, right? In order for us to convert this into relative frequency, relative to what? Relative to the total. So in order to actually figure out the total, we need to actually calculate this. Okay, let me give you a minute to actually compute that.
All right.
What do you get? What is the total?
149.
149. Very good. Okay, so therefore, in order to get the red, what will be your relative frequency for red? Will be 23 divided by 149. And if you put that into a calculator, 23 divided by 149, which gives me approximately, we'll just say 3 decimals, 0.154. 0.154, or let me actually do this. Or we could say, if we want it in percentages, 0.154, or we could say 15 point what? 4%. Get the idea, right? And that's what we did. So rather than going through and say, okay, let's draw a bar graph, because this is a categorical. So we have red, we have orange, we have yellow, and so forth. The red, rather than saying, okay, let's actually divide it up. So that's 10, that's 20, that's 30, that's 40, that's 50. Oh, now 15, 50. Okay, then the red here is going to be a bar that is 23, about right there. Okay, and then orange is going to be 44. Orange is going to be 44. You can say that, about like that, and so forth, right? You could draw a bar graph just like that, right? Okay, a relative frequency is basically you're just converting it into exactly the same thing. It's just that you, rather than this, we'll just say 10%, 20%, 30%, 40%, 50%, and so forth, right? And then we'll have the same thing. We'll have red to be 15.4%. So this will be 15.4%, just like that. Okay. And then the orange will be, if I want to calculate the orange, will be 44 out of 149 relative to the whole. Then we have 44. Let's convert that into a percentage. Will give you approximately 0.295, or we could say 29.5%. Then we could say, oh, orange is 29.5%, very close to 30%. Okay, that will be your relative frequency bar chart. Get the idea? So far, so good? Yeah. It's very similar. It's just one's in percentage, one's in what? A frequency. Okay, this is your frequency bar graph, right? And this will be your relative frequency bar graph. Okay, so far, so good. So that's where we get this right here. Okay, So we have the blue. This is different, right? They're using a different data. Okay, so far so good. All right, so how are we doing? We have 2 minutes. So here, did you guys read this portion? Justin, did you read that?
Which portion?
This one right here, pie chart. You should both already have gone through this right here. It's just telling you that, oh, pie chart is, right? Pie chart are very common practice, and you see pie charts everywhere on statistics, and if you go online, right, you have all these stats with a pie chart, right? Because it gives you an overview of the whole as a total, right? But pie chart are very common in practice, and that is not necessarily a good thing, because pie chart is very hard to compare from one to the other. As you can see, try this. 2014. So did company 2 or company 3 did better, or did company 2 or 3 have more market share? Which company had more market share, 2 or 3 in 2014?
3.
3.
You're like, oh, me too. I could eyeball it, but can you be definitive? How do you know that's actually, 3 did actually better than 2? You're like, I could eyeball it. 3 looks slightly bigger than 2, right? But it's hard to compare. It is extremely hard to compare, right? If you flip a coin, I could say, 2 could be it, right? I doubt it, but 2 could be it, right?
Yeah.
Now, let me see if you could answer this question. Which company did better going from 2014 to 2015? From here to here. How about black?
I think.
Did black do better going from 2014 to 2015?
No.
Company number 5. No?
No.
It seems like that's smaller, right? What about red?
Yeah.
Yeah, red looks like it, right? What about blue?
Yeah.
Kinda?
Yeah, me too. I think so, right? What about green?
Looks like they went
Looks
more.
like it stayed the same.
About the same, maybe slightly less, right? What about 4?
Yeah, a little bit.
Gosh darn it, this is hard, right? Right? When you look at something like this, right? Okay, so here, which company has the most momentum here? So of course they're asking you to, compare the three years in a row, right? Which one is growing, right? Momentum growing at a steady rate, right? Or bigger rate. So you can't actually tell. It's hard to actually look at it. But you go here. Can you see who, right?
Yeah.
Who did better, number 2 or number 3? Of course, number 3 right here, right? Okay,
Yeah.
as you can see in 2000, right? Number 3 is bigger than 2, right? Okay, what about here, right? And you can actually clearly compare from this bar to this bar right here. Okay, so therefore, it boils down to the people. People are bad at understanding area and volume intuitively, right? So they take, so they're just saying that sometimes, some graphs are much more superior than the other graphs, right? But bar graph, that doesn't mean that bar graph is always an inferior graph. No, sometimes, bar graph is useful in a way, okay? If you're not comparing, just looking as a total, right? It will be very useful to see as a total, right? But in comparison, this is hard. So, in comparing things, a bar graph is a better use of, comparison than the pie chart. Okay, so far so good. And there are key points here about pie chart to keep yourself being fooled by a pie chart. The first thing you want to do is add up the percentage. Always, they should. So the 3 key components that you need a pie chart is basically you want to know the subject of that pie sector. You want to know the 2 components, and you also want to know the subject, the number, and the percentage, basically. Okay, those are the 3 key things that you want to know. Okay, but basic idea is that you know, pie chart, there are a lot of misleading pie chart. If you look at something like this, when you look at it in 3D, it can be just very misleading. Oh, I have overstayed here. Okay, so I want you to go through the rest of this right here. You should have already went through this, right? The dot plots here and your stem and leaf plot, right? And then with your trainer and tutors, right? Go through these example problems here. Okay, if you have any question, ask them. Okay, and say, this is what I want to kind of go over, right? Can you explain to me this and that, right? Or can you help me answer this, and so forth. Got it? All right, so you should be going into your next, right, session, right, with your trainers, right? Trainees, right? Trainers, I'm sorry. Right, trainers from, what is it, from 3 to 3:50. Okay, so you'll have a little bit of break. I'm gonna go into my next one here. So I'm gonna let you guys go. All right, good seeing you both. Oh, Angelica and Justin, let me just. And Angelica?
Yeah.
What? Gonzalez and Justin.
What the Z? What the Z?
Z. Sorry. What group are you in?
Pink casuals.
Pink?
Mm-hmm.
So I'll just put pink here. And Justin?
Lavender, test row.
Okay, all right. So pink and lavender. All right. So I owe you guys MVP points. Okay. All right. Thank you for being here.
Thank you.
I'll see you guys tomorrow. Yes. Okay.
Okay.
All right.
Thank you.